Lesson 11 focuses on simplifying expressions. So this is the last lesson in Unit 1. So we're just going to begin starting to look at some algebraic terms and how to simplify them. So first thing you need to know is what an expression is. So an expression is whenever you combined a number and or variable with mathematical operations, and it can be used to represent a number. Um, so let's just look at some specific examples. It could just be a number. It could be a combination of some variables. So some examples here would be like negative 7y. That would be an expression. But I could also have something with operations in them. So I have x plus 7. So a variable and a number. You could have something like this, 2t minus 9. So you have some multiplication between the 2 and the t, but then you also have subtraction. And then another example would be like 4st minus 1/4 s, something like that. So basically, any kind of number or variable combined with adding or subtracting, and then in between each piece here is considered a term. So in between like the subtraction symbol or the plus symbol, each of those pieces there are terms. So that leads us to our next definition of what a term is. So a term is a number or a number and one or more variables multiplied together. So terms do not have adding or subtracting between them. They can only have multiplication as the operation. So if I'm looking at this previous example here, terms would be like negative 7y would be a term. Like the 2t would be a term because the operation is multiplication. It could just be a single number, so it could just be like 3. It could be a single variable, or it can be multiplying these. So I could have like that negative 1/4 s, but you can't have two terms pieced together, and then it becomes an expression. So then the last thing here are like terms. So what does it mean to be a like term? Well, it means when two or more terms with the same variable part, so meaning they have variables that are raised to the same power. So some examples of this would be like 2x and negative 3x. The 2 and the negative 3 are the coefficients, and then the x's are the same variable raised to the same exponent, which is 1 in both cases. You could have something like this, 18x squared y and 2x squared y. So notice that the variable part is exactly the same. It has x squared y, 2x squared, and y. An example of something that wouldn't be a like term would be if I had 18x squared y and 2xy squared. So these are not like terms, and the reason is if you look at the exponents, I have an x squared and a y, where over here is an x and a y squared. So the exponents have to be exactly the same in order to be like terms. So then let's look at some examples of how do we simplify expressions based on like terms. So this first example here, so 3x plus 4x. So yes, they're like terms. So basically what you're going to do is you're going to keep the x and you're going to add the numbers in front. So we have 7x. When you think of combining like terms, you really want to think of like totaling up. Tell me, how many x's do I have? Well, I had 3 of them, then I got 4 more, so together I have 7. So that's kind of what you're thinking about when you're combining like terms. So what if I have something like this? 3x plus 5 plus 2x minus 3. Now normally, automatically, you start grouping your like terms. You start looking at, okay, 2x and 3x are like terms, and the 5 and the negative 3 are like terms. So basically, we could just, kind of do the math in our head, but just to show you for this one example, we can rearrange these. So I can rearrange that 3x plus 2x and group them together because of the commutative property. I can switch the order of the 5 and the 2x. And then I'm left with the plus 5 minus 3. And then you just do each of the operations here. So I have 3x plus 2x gives me 5x, and then I have 5 minus 2, or 5 minus 3 gives me 2. And that's as far as I can go because I can't combine the 5x and the 2 because they're not like terms. So let's look at another example. So I have 4a minus 7b minus 2a plus 3b. So your first goal here is to identify your like terms. So I have a 4a and I have a negative 2a. And then I have a minus 7b, which is a like term with this plus 3b. So you can rearrange and group them if you want, but you start getting used to it where you don't need to actually rewrite it. So I'm just going to go ahead and say, well, I'm going to add the 4a and I'm going to subtract that 2a. So I'm going to have 2a from that. And then I have the negative 7 plus 3. So the negative 7 plus 3, well, I had negative 7 b's. I'm adding 3 more b's. So I'm going to be left with a negative 4b. Remember the rules for adding integers. You basically subtract when they're opposite signs, and you keep the value of the larger absolute value. So I keep the negative because 7 is bigger than 3. So your answer is 2 minus 4b. And let's look at one last one of these. So we're just going to simplify. So we have 5 times x minus 2 minus 3x plus 4. So first thing, we got to use the distributive property. We have to get rid of these parentheses. Same with this negative. Remember, it's like thinking of a negative 1 out in front. So I'm going to have 5 times x gives me 5x. Don't forget about the negative signs. We get minus 10 when we multiply 5 times negative 2. You're essentially flipping all of the signs in the second piece. You're basically negating each piece. So negative 3x minus 4. Now we identify the like terms. So I have 5x and I have a negative 3x. Then I have a minus 10 and a minus 4. So I'll go ahead and combine them. 5x minus 3x gives me 2x. Remember, you're subtracting the coefficients, the numbers in front, keeping the x. You're telling me if you had 5 of these x's and you take 3 away, you only have 2 left. So you're not changing the x in any way. You're just telling me how many do you have. Negative 10 plus negative 4, or negative 10 minus 4, it's the same thing as thinking of it as adding with the same sign. So adding with the same sign, you actually add, and then you keep the sign. So you have 2x minus 14. And then there's one other type of example with these expressions. And so let's look at that. If we have this expression 2x minus 3y plus 4, and we want to find the value of this whenever we know that x equals negative 5 and y equals 6. So essentially what you're doing is you're just going to substitute these values in. So when I substitute in, so let me first just rewrite it. And then when I substitute in, I always substitute in with parentheses. It's just a good habit to get into because it helps you kind of keep those negative signs straight, especially when we are raising numbers to an exponent. So all I did was I plugged in negative 5 for x and plugged in 6 for y, and I'm just going to evaluate it. So 2 times negative 5 is negative 10, minus 3 times 6 is 18, plus 4. PEMDAS says in this case, we have subtraction and addition, so they're in the same priority, so you just work left to right. So negative 10 minus 18, so negative 28, because we are keeping the sign and we are just adding, plus 4. Now we have opposite signs, so we subtract, so 28 minus 4 gives me 24. And you keep the sign of the larger absolute value, so your answer for this is going to be negative 24. So that's it for this unit. So the next thing you're going to do is you're going to start working on some review problems so that you can get ready for your unit exam.